some practical machine learning fundamentals, and that's what we shall look at in this presentation. What we want to pick out from this presentation is we want to understand the idea of classification, the concept of linear separability of a data set, and we can tune parameters of a classifier and how do they relate to a decision boundary. Then also briefly look at TensorFlow. Okay. So first, I do hope does everyone have this notebook, because it will be actually much better if people could follow through with this. I wanted to share. Does everyone have this? Can I ask that? Hello? Okay, let me share the notebook. Okay, sharing soon in the comments. You will be receiving the link in the comments soon. Just let me just put it up right there now. Just give me a second. Okay. Put it in here. To attach a file. How can I send this file? Who can help me? Mr. Bruno.
Isaac, you can
yes.
you can just share with us, and we shall see how to get it to the participants. Bruno, Timo,
Okay.
Timothy, support on this, please.
Okay.
Okay, fine.
So just assume that you will get the file time. So, but for this particular exercise, you need to know is you have dependencies. You need to have, you need to install MoviePy, ImageIO, and TensorFlow. You can do this in notebooks. You can run terminal command notebooks by just adding the exclamation mark sign. And if you run this cell, it should be able to run this dependency. You also need matplotlib. You also need NumPy. So if you don't have NumPy, you need to install NumPy as well. You need to install NumPy as well. And so if you get any, you try to run these cells and you get any error, you need to make sure that you install those dependencies. For example, if I run this and I get some errors, I should install whatever is missing. Okay. So we in this this notebook we are looking for data which we're going to random data. We shall be able to perform some machine learning classification tasks. Classification deals with basically mapping input into an output into a discrete output space, whereas regression learning your map inputs to a continuous valued output space. So classification we mean something discrete, either 0 or 1, that belong in this class or the other class. Regression, you have continuous variable output, like analog of nature, and classification is more of digital. We okay. We did some helper functions. We will need a function that's going to help us plot to plot some some graph. We're going to plot some outputs. So we've defined a plot data set function, which is going to it's a scatter plot with, and we have two labels, red and blue. So we'll have data. Our data will be in red and blue classes. So we want an axis. We want to have our data scaled so that we can understand and explain. Um, so what of examples of problem we solve using binary classification? You can determine whether an email is spam or ham. You want to determine whether email contains spam content or not. And you can also use image recognition. Try using image pictures, using pixels of an image, RGB image, to identify where it's a dog cat. Okay, so we need data. Every machine learning task needs data. So the beginning is always data. You need some source of data. You either collect it somewhere manually, either from an analog space into a digital using some sort of sensor. But particular example here, we are going to randomize some data. And we are using random seed. You will, once you notebook, most important thing, you need to run all this because it's already made. The box is no code to add on. So the first thing that you need to do is to run all these cells, able to see the output up to the very end. You can now try to understand how it's actually coded. So right now, pointing out a few things that will guide you, will help you started. Random seed. Um, why we use random? We use a random seed is because we to maintain the replicability of our data. So that when this is randomly generated, which you use will be able to run, will be able to the same exact data that I am seeing here. So random seed a good trick to help us create the same data. And then we go ahead and generate data for the red. We have two classes, binary classifier. So we have two classes, the red or blue, or one. Some comments in here. Okay, let me just make sure all of us are okay. Okay. Yes, I see people are in the notebook. Okay. Okay, issues the software install, with the installs. It may take some time. Okay, I'll just continue. Yeah, so after that, we will plot our data by passing in the inputs and the labels, which we have generated from here, from this code. The function, it has come into the plot data. It's right here, which is just snapshot of our data, and you can see the scale is quite good. See, we have two groups of data in this. We have the the red class, the blue class. So we need to pass this to a machine algorithm, and then okay, let's look at how data looks. It's in a 2D space. That means each point that you see on this plot has two coordinates. It has an X and Y coordinate, but in this case we have X1, X2 coordinate. Each of these represents input to our data space. So these are like called features. Okay, I'm seeing some points. Okay. You have the notebook with you soon. Okay, I'll continue. Um, sorry, am I in the right place? Nope. Okay. Okay. Sorry for that. So we'll print out data to look at. We'll print out the first point, and the x1 and x2 coordinates. So this is one feature, and this is another feature. So the next point in a set, we the indices slices here to get the position of the data. So this is the last one, and this is the second, and so on. So you can be able to print about 20 points. And also the label, so we can be able to the labels for different data points. And so we can see there are those that in one and in the other. So red or so what you realize here is that we are not using red or blue. We have encoded the labels. We have encoded the labels into something called one hot encoding. Have one binary classification type. Encoding is binary, 0 or 1. So linear separability helps us to understand the decision boundary for our learning task. What we want to do is basically draw a line which separates these two, because the machine learning is to help us to identify whether a point belongs in a red class or blue class. So we need to define that boundary between those two classes so that we can make our prediction. So linear separability is just us having the ability to separate the data in properly. That's a good decision boundary. That to the of the how do we determine that line? So that line is determined from equation, which is represented by variable, the feature of, and the weight W1. So we have added a new aspect of our data, which is the weights, which is one W2. So line has to take into account the way the line looks will be determined those. So we can try to out and see how it looks. So now okay, I'm seeing more comments. Let me just to be sure it's not. Some people seem to be having some network issues, but I hope that you have the notebook already. You should be trying out. Okay. Um, let's continue. We have we will define parameters. We want to go ahead and look at how that looks like with these parameters. So, and we giving them a range between -5 with steps of 0.1. So we have initialized W at -1 and W at 1. So then we go ahead and plot data set and then add on some extra plots to uh, the decision boundary. Okay. And you can see here, we have defined that our decision boundary by using W1 and W2, -1 and 1. Okay. So usually the question is how good is the line? Do you evaluate line is actually good? And that's why we subject. That's why we subject our algorithm to specify some loss or objective function. Because the parameter, the loss of this function is the loss is a function of parameters W1 and W2, and basically it's how good the configuration of those parameter values are in the data, and this is what parameterized. So you basically have some features which you keep making and improves output accuracy of your model. So there are things that we'll look at later on with TensorFlow, see how you can use gradient-based optimization algorithms like descent to help us to optimum value W1 and W2. Okay, so for this classification problem, we will consider the cross entropy function, which basically gives us the measure of how the model predictions are. So what basically happens that the loss looks at the prediction for each example compared to the true target value of y. So and then applies non-log linear function to penalize the and output the binary entropy function is an operation called a sigmoid function at the output. And what a function is that it finds our output between 0 and 1. So lowest value out you can get 0 and the maximum is 1. So you can have a sigmoid function which is from -1, 0 to 1. So how your sigmoid function looks, and you don't really have to understand mathematics right, but you can go through it later with time just to see the output. But we didn't show a sigmoid function. We're going to define a function that helps us to compute the loss for any values of W1 and W2. So this loss function is now is we are looking at just the input variables. Now we've added extra variables into makes it W1 and W2, and our loss function help us to compute which values of W1 and W2 give uh, a good loss. This is our code right here. So we need to add all the data we have, and then the prediction is going to be provided by the sigmoid function, which is a layer within the TensorFlow. We imported TensorFlow TF, so you see tf.sigmoid, pass the weights to data right here, then perform the conversions. As you can see, our sigmoid function is just right here. Okay, so then we return the average loss. To get the average, we get the loss divided by the size of our data set, and then we return average loss. Okay, so you can see how plot looks like. Sigmoid function. We say this value. If you look on the y-axis, on the axis, you can see the range, the lowest from 0.0 0.0. So this is our sigmoid function. Okay, we have questions so far. Okay, some volume questions. Yeah, I think the notebook has been shared in Drive. I think that has been shared by the admins. So just trying to check out that link as well. Okay, I see it's just crash course. I don't seem to see this other.
Isaac, can you please share your file as well? This is for Alan.
Pardon?
Can you please share your file? This is for Alan, yes.
Oh, no, Bruno has shared. It's finally, you can now get it. He has just in the chat. So please, I would you go, you click on that, you will be able to get the file. Oh, okay. I'm just known for a few seconds that everyone has gotten the file. Trying to look through any questions, particular. Yes, let me have some feedback from the T. So I'll just continue. Okay, so now we need to add the loss for our chosen values W1 and W2, and Oh, we need to visualize the loss. So we need to look at the loss. We select a random values in of W1 and W2, and now we need to look at what are those optimal values which were giving us a good loss. Okay, yeah. So everyone is notebook, which is good to the team. Okay, so at this particular of values of W1 and W2 have given us a loss value of 0.09. And it shows us where the decision lies. We need to visualize loss function within range of W1 and W value. Okay, someone looking for yeah, is okay. Okay. So can do that using a contour plot. Is basically a technique of visualizing a 3D function on a 2D. So the contours represent that dimension. So we provide our data as and we provide a loss function right, and we specify the inputs W1, W2, and the labels, and then we apply the loss and append it some array. So we pack these for every value of W1, W2, and then we go ahead and plot loss value. So you see on contour plot on the x-axis you have the W1 value, the y-axis W2 value. So you have ranges the W1 and W2 values ranging from -4 to +4. We are looking for any between -4 and +4, which gives us good. So as you see here, a legend right, binary cross entropy loss, and you can see this visible spectrum shows us that at blue we have the lowest loss value, and towards dark red you have high loss values. So that any value of W1 which is close to 4 will give us. So you just look at the contour plot and you see where is those regions of those color spectrums which give you the particular different values of W1 and W2. Let me check once more. Okay, everyone's notebook. So I would suggest that everyone tries this out, and then we can be able to. Okay, so we cannot then use Tensor to optimize so we are using a learning learning meter is really how quick are we at living at our gradient algorithm, quick is it at at the bottom of the cup. So learning it's trivial. It's not trivial, and trivial setting the learning rate parameter. It's something that you pick. So specify the W and W2 our weights. We specify epochs, and here we're running 100 epochs. Then we compute the loss, and then we're using gradient descent rhythm. Then we go ahead, we plot plots to see what happens. So if you've already TensorFlow, be able to run this, and you should be able to have some output. So we'll wait for that to run. I'll just keep checking if there are any more questions. Please, I welcome questions. Okay, that's good. Okay, TensorFlow has yes, so you need to install TensorFlow. But in pip install TensorFlow, you're able to get it. Okay. Any questions? Because I think I have come to the end of my presentation. I just need to hear questions, especially on notebook. Yes, there's a question, do we always have a loss function? We do not always have a loss, but we need a function because it basically helps to tell us how good our parameters are at helping us to achieve the accuracy that we need. So we always need loss function. And this will be accentuated by our analyst who's going to give us a deep dive into learning and neural networks. Looking forward to any questions. The system cannot find specified. Okay. I would suggest first and foremost to use you can virtual environment. Can just virtual pip install virtual environment, virtual env, sorry, pip install virtual env. I suggest use virtual environment. You can create a virtual environment. Okay, let me just put it in the chat. Okay. Yeah, so machine learning is uh, basically you have some input data you want to create as you want to learn from, and then provide make some predictions on and predict an outcome in the future. Um, so we use machine learning to make predictions. Uh, we have learned patterns from some data. We want to make predictions for um, some unknown uh, events. So I can briefly talk about machine learning. Okay, I talk about virtual environments is because you will be able to have all your dependence in one space, so you don't have to run problems of conflicting installations and backed up libraries which fit your main environment. Okay, still waiting for questions. If I to hear some, especially on the notebook. Okay, so I think we are done. We don't have okay. Yeah, so some directions use Google Collab. So I hope you can see my screen. You need to create an account first. So that's thing with Google Collab. Don't really need to these instances. They have been installed. So you just basically run your notebooks. You just upload your notebook. Selected the notebook. So yeah, I can now begin to run. So you can upload your notebook to Collab, and you to take advantage of. So you can see Excel has successfully run, import TensorFlow TF, and what you notice is did not do any installation of TensorFlow. I'm sure some be grappling with to install TensorFlow because it's quite a big page, but I have just this within seconds and I've been able to import TensorFlow. I can go ahead and use engines to do these running tasks. And so I'll be able to import things as well, like NumPy, Matplotlib, and so forth. And right in this cell here, you can see that TensorFlow is already executing, and these other dependencies run just off the fly without me having to install anything. It decreases the amount of time it takes to test your new applications. So it helps you to get running very fast, and you can test things and don't have access machine. You can be able to do this on the cloud from anywhere. You don't need to have a good device. You just run it over the cloud. Thank you very much. It was